Okay, here's Lab 1 Part 1, and we have the circuit set up. I'm going to go into Multisim and hit play or start. Okay, right now, as we can see, the LED is lit up, and that's because there is no input going in right now. But if I change that input to a 1, my LED light goes off, so therefore I created an inverter. Again, so now the signal is 1, LED is off, signal is 0, LED goes to on. So now we'll go ahead and build this on the breadboard. But part 2 is actually going to have us do something different. We're going to, instead of a manual switch, we're going to set it up on a function generator, which goes at 1 hertz. So this should go blink the light on and off every second. And there we can see we turned on the function generator, and we should see there our LED is on, and now our LED is off. There the red LED is back on, and it's back off. So that was our circuit simulation run on Multisim, so now we can go ahead and build it on the breadboard. Okay, this is part 1 of the Lab 1, and we can see right now the digital writer, it is set to write high. That's right up here. When I switch it to low, right, by clicking once, then the LED will go on, and that's this LED right there. So I'll switch it back to high, and it goes off, and to low it goes on. So therefore my inverter is functioning correctly. High, low, high, low. Okay, now we're going to demonstrate the function generator on this circuit. This should make the LED blink at a frequency that we have set of 1 hertz. We have it set to 3 volts peak to peak, and we're ready to start. First I'll ground my circuit, so as we can see there's no signal, it's 0, and the LED right here is on. And as soon as I'm going to push the red, or the run button, the green run button on function generator, and I'll start my signal going through. And now I'm sending a 1 hertz signal through on my function generator, and therefore our inverter circuit is blinking the LED at 1 blink per second. Okay, this is a demonstration of the AND gate built with 2 diodes. We have 2 inputs here, input A and input B. Right now they're each at 0, and here's our LED that should be our indicator of our high or low of the result of our function. So I'll go ahead and start the simulation. First I'm going to switch A to a 1. Now you can see A is 1 but B is 0, and the LED is not lit up. So now we'll go for A to be 0 and B to get 1, B1. Still no indication on our LED. Now we'll go A and B are 1. A is 1, B is 1, and now the LED is lit up. If I remove either one, I remove the B down to a 0, it goes off. Or I remove the A down to a 0, it goes off. And of course I turn them both back on, and it's on. Now we're going to put the B down to 0, and we're going to disconnect the A. Guess we're processing. Okay, now I've connected the A input to a function generator going at 1 hertz. So that's 1 cycle per second. And so with our B at 0 and our function generator running, there's still no indicator on the LED. Now I'm going to switch the B input to a high, and now we can see our LED goes on. And it will go off now without me doing anything because the function generator. And it's on again, and it will shortly go off when the function generator goes low. So now we're ready to build this circuit. Okay, now we have the AND logic circuit set up. This was the one we looked at earlier. And what we're going to do, we notice here's the digital writer. You put 1 high, nothing happens. You put 0 high, nothing happens. Or if you put both of them high, the LED goes on. Okay, I can shut either one off and it will shut off my LED. What I'm going to do is I can leave 1 high. I'm going to disconnect from my digital writer so we won't be using both portions of that. And now we're going to go over to the function generator. So I'm switching one of the pins to the analog output. And so now our function generator is going to be used. So what I'm doing is I'm running a 1 hertz signal, square wave, 3 volts peak to peak. And when I turn on just one of the inputs that's going into the diode, now I'm getting a blinking signal, on then off, on then off. Earlier I had a problem and it was going from bright to dim, and the solution to that ended up being using the DC level output rather than just using the 5 volts source, digital source from myDAQ. So for whatever reason, if I go to analog output number 1 and use my DC, that works, and set it to 5 volts, it works where the digital 5 volt did not work. So there we go, the function generator is setting off the LED, and then again, since it's an AND circuit, I kill my digital writer on one of them and it stops blinking. I turn it back on and the blinking commences. Okay, now this circuit demonstrates an OR gate with 2 diodes. You can see I have 2 digital inputs, A and B. Here's my LED. Right now it's off. If I set A, click in here. If I set A to 1, the LED goes on. If I keep B on, it also stays illuminated. If I turn A off, so only B is on, and it's illuminated still. So the only way to have the LED off is to have A and B in the low position. We can also take off A so it's no longer a manual input, and we'll put it to a function generator. And of course we're going to do our favorite speed of 1 hertz. And I start. Okay, and there it goes off. It's on and off. The LED is blinking. Here's B. That's because B is in the low position. However, if I do switch B to the high position, even though the function generator is going on and off, it's always going to remain illuminated because this is an OR gate. And so I'll turn it off to enjoy some more blinking, and that's how this circuit works. And now I'm going to get ready to build it on the breadboard. Okay, this is our circuit of our OR gate. Now we're going to go ahead and put it onto the breadboard and show how it works. Oops. Okay, here it is on the breadboard. We're going to need to open up our function generator. And we'll go ahead and make sure the circuit works. Right now we can see the LED is not lit up. When I hit 1 high, it goes on, or if I hit 0 high, it goes on. Also, it should, with both, it stays on. So there we do have it working. Now we're going to go ahead and switch to a function generator. So I'll take out one of the digital writer inputs and change it with the function generator input. Function generator is going off at 1 hertz. We're doing a square wave, 3 volts peak to peak. And I'm running, but there's no illumination on the LED. So what's the problem? To investigate, I'll open up the oscilloscope. I am creating a square wave, 1 volt divisions. It is about 3.3 volts. However, our voltage is barely getting in the positive range. So I'm going to try doing a DC offset of 1.65 volts, which is half the voltage of there. We'll see how that changes our signal. Okay, now our signal is a lot closer to a 3 volts all in the positive direction, and we notice our LED did begin to blink. So I guess that's just the fix for this lab, to make the light blink. And this is the OR circuit generating a light by the function generator.